Welcome to Tech Disruptions, deep dives into the technologies reshaping industries, from AI to quantum to biotech. Let's get into it. Okay, so imagine this. You wake up, open your laptop, and there's a notification from an AI. It says, "Good morning. I just spent the night autonomously discovering thousands of critical, unpatched, zero-day vulnerabilities across every major operating system and web browser. Oh, and I did it for less than $50.
And the kicker? The company that built this AI, Anthropic, immediately locked it down. They said, no, you can't have it. They're treating it less like a product launch and more like a national security disclosure.
Exactly. They created an AI Manhattan project for defensive cybersecurity called Project Glasswing, backed by $100 million in AI credits and millions more in open source donations. This isn't move fast and break things. This is we just broke everything, so here's a coalition to help you put it back together.
It's absolutely wild. This isn't some coding assistant anymore. This is a fully autonomous, elite-level hacker AI. And the scariest part? It found a 27-year-old bug in OpenBSD, the operating system infamous for its fanatical security. 27 years.
27 years. Since 1998, the Clinton administration. That's how old this bug is. And it cost $50 for an AI to find it. I mean, we've been talking about AI's impact on coding, but this feels different. This isn't just about writing code faster. It's about fundamentally altering the security equilibrium of the entire internet.
It absolutely is. And to really grasp why Anthropic made the unprecedented decision to restrict access to Claude Mythos Preview, you have to look at the sheer leap in capabilities over their previous frontier model, Claude Opus 4.6. We're not talking about incremental improvements here.
Oh, you're talking about the Firefox 147 benchmark. I saw that in the report, and my jaw just dropped.
Right? So Anthropic tested these models against known vulnerabilities in Mozilla's Firefox 147 JavaScript engine. Opus 4.6, their previous best, could turn those vulnerabilities into working JavaScript shell exploits only twice out of several hundred attempts. It was basically a near-zero success rate for autonomous exploit development.
So it wasn't really a hacker AI at that point, more like a very, very confused assistant.
Precisely. Now, Mythos Preview, given the exact same benchmark, it developed working exploits 181 times and achieved register control on 29 additional attempts. That's not a marginal improvement. That's a paradigm shift. It went from effectively zero to consistently weaponizing vulnerabilities.
181 times versus 2? I don't even have a percentage for that. That's a galactic leap. And the report had this chilling anecdote about the non-expert weaponization.
Oh, the one where Anthropic engineers with zero formal security training set up a Mythos agent, asked it to find remote code execution vulnerabilities overnight, and then woke up the next morning to complete working exploits. Yeah, that one still gives me goosebumps.
Right? It completely demolishes the skill barrier. We've always relied on the fact that elite hacking takes years of specialized knowledge, deep understanding of systems, reverse engineering. Now you just prompt an AI. It's like going from needing to be a master blacksmith to just pressing a button on a 3D printer.
It's exactly that analogy. And this is why the debate around restricting access is so crucial. Anthropic's argument is that they're buying the internet time to patch by keeping this under wraps and working with Project Glasswing partners. But if engineers with no security background can generate 0 days overnight, what happens when an open source model achieves similar capabilities? Is Anthropic really protecting us or just delaying the inevitable?
It's an impossible question, really, because if they had released it, it would have been absolute chaos. But the genie is clearly out of the bottle conceptually. The knowledge is there, in the algorithms, and the speed at which this AI found things, like those ancient bugs, it's truly mind-boggling.
That's where it gets really interesting. This AI isn't just good at finding new stuff. It's astonishingly good at unearthing flaws that have been hiding in plain sight for decades. The OpenBSD bug we talked about earlier, the 27-year-old one?
OpenBSD, the operating system that proudly boasts about having only 2 remote holes in the default install in a heck of a long time. Their entire brand is built around security paranoia.
Exactly. And Mythos found a fatal flaw in their TCP stack that had been there since 1998. It lives in the TCP SAC, Selective Acknowledgement Implementation. Basically, Mythos realized that a variable called sac.start was never validated against the lower bound of the send window. It spotted that the CEQ macros would suffer a signed integer overflow when values were exactly 2 to the 31 apart.
Wait, so it understood the subtle mathematical properties of these comparisons and how a specific, obscure input could trigger a crash? That's not just pattern matching.
Not at all. By carefully choosing a sac.start value, an attacker can satisfy contradictory mathematical comparisons, which then triggers a code path where all holes in the tracking list are deleted, leaving a pointer, p, as null. And when the code tries to execute p.next equals temp, boom, null pointer dereference. 2 crafted packets and any OpenBSD server responding over TCP crashes.
2 packets. And the cost? We mentioned it earlier, but it bears repeating. Anthropic spent about $20,000 on the entire OpenBSD discovery campaign, but that specific AI run that found this 27-year-old bug cost under $50.
$50 to remotely crash the most security-hardened OS on the planet with a bug that's been there for nearly 3 decades. It's a stark illustration of the economic inversion this AI brings. And it's not an isolated incident.
You're talking about FFmpeg, the video encoding library? That's in everything. Browsers, media players, streaming apps?
Yep. Mythos found a 16-year-old out-of-bounds write vulnerability in its H.264 codec. The underlying bug dates back to 2003, but became exploitable during a 2010 refactor. It involves a 16-bit versus 32-bit slice counter collision. The code uses memset, -1, etc. to initialize an array, which fills every byte with FF.
Okay, so it's a common pattern, setting a buffer with -1 to indicate empty or not set.
Right. But then, when the slice count hits 65,536, slice number 65,535 collides exactly with that -1 sentinel value. That allows an attacker to write out of bounds. And here's the kicker. Anthropic noted that automated fuzzers had hit this exact vulnerable code path 5 million times without triggering the flaw.
5 million times? And they missed it?
Because fuzzers just throw random garbage at code hoping something breaks. Mythos, on the other hand, actually read the code. It understood the semantic meaning of that sentinel value and then engineered the exact mathematical state needed to trigger the flaw. This isn't brute force. This is semantic reasoning.
This is the critical takeaway, isn't it? Human code review and traditional automated fuzzing have clearly hit a ceiling. Mythos is catching unknown unknowns, these incredibly complex, multi-step compositional flaws where components that seem safe on their own interact in unsafe ways. If OpenBSD, the most paranoid OS on Earth, had a remote crash bug sitting there since the Clinton administration, what is hiding in the software running our banks and hospitals?
It's a terrifying thought. And for years now, the tech industry's favorite security mantra has been rewrite it in Rust or Java. These are memory-safe languages, specifically designed to prevent the buffer overflows and memory corruption issues that plague C and C++. Everyone thought they were the silver bullet.
But Mythos Preview just proved that that defense is an illusion, at least at the hardware boundary.
Exactly. It found a critical guest-to-host memory corruption vulnerability in a production virtual machine monitor, a VMM, written entirely in Rust. VMMs are the foundational software of the public cloud. They ensure your workload on AWS or Azure is strictly isolated from some potentially malicious workload running on the same physical server.
So, if a malicious guest can escape their virtual machine and write to the host process memory, then cloud isolation is fundamentally broken. My workload can read your workload, or worse, manipulate it.
And it all comes down to the unsafe keyword in Rust, or JNI in Java. As Anthropic researchers pointed out, pointers are real. They're what the hardware understands. To talk to the physical CPU or a network card or any low-level system, even memory-safe languages must use these unsafe blocks. Mythos identified a vulnerability living precisely inside one of these unsafe operations, chaining pointer operations to achieve arbitrary host process writes.
We spent the last decade telling developers to rewrite everything in Rust. Mythos just looked at the unsafe interop boundaries and laughed. This is huge for enterprise listeners. If cloud isolation can be breached like this, it undermines the very foundation of modern computing infrastructure. It's no wonder all the major cloud providers, AWS, Google, Microsoft, are founding members of Project Glasswing. They realize their foundational architecture is currently vulnerable to AI-generated exploits.
100%. It's a direct threat to their core business model. And it's not just about finding the bug. Finding a bug is one thing. Writing a functional exploit to weaponize it is an entirely different, highly specialized skill. It requires deep understanding of system architecture, memory layouts, bypassing defenses.
Yeah, that's what always separated the truly elite hackers from mere vulnerability discoverers. You can find a flaw, but can you turn it into a working exploit that gives you control?
Mythos Preview proved it can do both, autonomously, and the FreeBSD RCE CVE 2026-474 is the perfect example. On March 26, 2026, FreeBSD published an advisory crediting Nicholas Carlini, using Claude, Anthropic, for discovering a remote kernel code execution vulnerability.
So it's not just about crashing a system like the OpenBSD bug, it's taking full control.
Exactly. The flaw was in the kernel's NFS server, specifically in the kgsSPI.co module that handles RPC SecGSS authentication. The code reconstructs an RPC header into a 128-byte stack buffer. It writes 32 bytes of fixed header data, leaving 96 bytes. But then it copies the credential body, OA length, into the remaining space without any check if OA length is larger than 96 bytes.
Classic buffer overflow, but on a kernel.
Any credential larger than 96 bytes overflows the stack buffer, overwriting the return address. But here's where it gets truly next level. Modern operating systems use defenses like kernel address space layout randomization to prevent simple stack smashing. To bypass this, Mythos built a complex 20-gadget return-oriented programming chain.
A ROP chain? That's an extremely advanced technique. That requires understanding specific instruction sequences within the kernel that can be chained together to execute arbitrary code, even when you can't inject your own. And it does that autonomously?
Not only that, because of network packet size limits, Mythos couldn't send the entire exploit all at once. It autonomously split the attack across 6 sequential RPC requests. And the payload? It successfully dropped a root reverse shell and appended SSH keys to /root//SSH/authorized keys, granting full, unauthenticated remote root access to the server.
This is astonishing. So it's not just finding the bug, it's understanding the memory, understanding the OS defenses, understanding the network protocols, and then choreographing a multi-stage, multi-packet attack to achieve root access. How did it even do that? Did Anthropic researchers guide it step by step?
Not really. They spun up an isolated container, provided the FreeBSD source code, and gave a generic prompt to find vulnerabilities. Mythos operated in an agentic loop. It read the code, hypothesized the overflow, and wrote a test script. When its initial stack offsets from disassembly were wrong, the AI autonomously generated De Bruin patterns, a classic exploit development technique, to read the crash dumps and correct its own offsets.
It debugged its own exploit.
Yes, and when it encountered a hardware breakpoint bug that crashed its child process, it debugged its own exploit, used kern execvive to replace the process with /binsh, and successfully transitioned to user mode. Think of it like a chess engine. In the 90s, chess engines just calculated brute force moves. Today, AI is playing cybersecurity chess, thinking 20 moves ahead, setting up memory layouts, debugging its own mistakes, and executing a flawless checkmate against an operating system.
That's a perfect analogy. It's truly agentic behavior, not just a tool. This isn't just autocomplete for hackers, it is the hacker. This changes everything, and it brings us to the defender's dilemma. What do we do now?
Well, the immediate problem is the sheer scale. According to Nicholas Carlini, the expert in adversarial machine learning who worked with the model, over 99% of the vulnerabilities Mythos has found are still unpatched.
99%? That's a mind-boggling backlog.
And because Anthropic can't publicly disclose the bugs without handing attackers a roadmap, they are publishing SHA-3 hashes to cryptographically prove they found the bugs first while they work privately with vendors. But the public Glasswing report is slated for early July 2026. Cybersecurity analysts are warning boards of a coming patch tsunami. Security directors who haven't expanded their patch pipelines are about to be overwhelmed.
Anthropic is playing God right now. They are sitting on a dragon's hoard of 0 days, handing them out to their 11 corporate best friends in Project Glasswing. What happens if the model weights leak tomorrow? Or if an open source model achieves similar capabilities soon, which seems inevitable?
That's the core of the jagged frontier problem. Anthropic's thesis is that while attackers get a short-term boost, defenders will ultimately win by using these models to fix code before it ever ships. But is the moat actually defensible? An AI cybersecurity startup called Isle tested Anthropic's showcase vulnerabilities against smaller open weights models. They found that an open model with just 3.6 billion parameters, costing 11 cents per million tokens, successfully detected the FreeBSD exploit.
So a cheap open source model can already replicate some of these findings?
A 5.1 billion parameter open model successfully recovered the core analysis chain of that 27-year-old OpenBSD bug. Isle concluded that the moat in AI cybersecurity is the system, not the model. The scaffolding, the agentic loop of compiling, debugging, and testing is what makes Mythos dangerous. As open-source scaffolding improves, anyone will be able to replicate Anthropic's results using cheap, uncensored models.
This completely inverts the economics of hacking, doesn't it? A human security researcher capable of finding a 27-year-old OpenBSD TCP vulnerability bills at $300 to $500 per hour and might spend weeks on the project. A single Claude Mythos discovery run costs under $50.
And according to CrowdStrike's 2026 Global Threat Report, the average time to exploit has dropped to just 5 days, down from 30 days in 2022. If an AI can do weeks of elite vulnerability research for the price of a nice dinner, the entire economic model of offensive and defensive security has to be rewritten. The bug bounty hunter, the penetration tester, the entire profession, it all changes.
This is a truly watershed moment. So, if we had to distill this down, what are the absolute key takeaways for our listeners?
First, AI has undeniably crossed the threshold from a coding assistant to a fully autonomous agent. Mythos isn't just autocomplete. It reads crash dumps, corrects its own memory offsets, and writes 20 gadget ROB chains. It's an autonomous penetration tester. That's a fundamental shift.
And second, it's proven that decades-old bugs are hiding in plain sight. That 27-year-old OpenBSD bug, the 16-year-old FFFmpeg flaw, these semantic logic flaws were missed by human auditing and traditional fuzzing for years. It's catching the unknown unknowns.
Third, the idea that memory-safe languages like Rust and Java are a silver bullet for security, that's an illusion at the hardware boundary. Mythos showed that the unsafe seams where software talks to hardware are highly vulnerable. Cloud isolation is not as robust as we thought.
And finally, that impending patch tsunami is very, very real. Anthropic is sitting on a dragon's hoard of 0 days, working with a select few partners. But the scale of unpatched vulnerabilities, the speed of discovery, and the looming public disclosure in July 2026 means we're in for a massive upheaval.
It's an unprecedented situation.
So the big question then is, what happens if these model weights, or even just the advanced agentic scaffolding, leak? And how do we, as an industry and as a society, fundamentally change our approach to software development and security to address this new reality where an AI can find and exploit anything for pennies?
We've got our work cut out for us.
That's all for this episode of Tech Disruptions. Join us next time as we keep exploring the technologies reshaping our world. Thanks for listening. We'll see you next time.
Stay curious out there.